Hi guys, thanks for watching this video. Today I'll be talking about some basics when filtering and slicing data in Pandas. I'll be covering how to import a data set, a few functions on how to explore a data set, and then I'll cover a few basic methods and functions on filtering and aggregating data. The goal isn't really to dive deep into any of these topics, but what I'll try to do is cover them broadly to show you the functionality of Pandas so that you can try it for yourself. So I will also have this Python notebook in the link below so you can follow closely with me. But what I'll also put up are some exercises that you can do to just reinforce the things that you've learned. All right, and so this lecture will aim to show you a big reason why people like to use Pandas in data science and in analytics. The goal is to show you how easy it is to explore and manipulate data using Pandas. So again, follow along with me in the Python notebook. By downloading the Python notebook in the link below, you can either open up the notebook in either Jupyter Notebooks or in Google Labs. I have it open in Google Labs as you see here. So let's get started by importing the dataset. So I'm going to actually use a Python library function to import the dataset. I first need to import that dataset into Google Colabs. And in order to do that, I am going to open up this left nav bar. The third icon here will have the Titanic CSV. So I already have it loaded into the Google server. If you don't, obviously, you can just press this upload and it will go to your downloads folder or whatever folder in your computer, and then just select the Titanic CSV file. The CSV file is also linked in the description below, so go ahead and download that dataset now so that you can upload it with me. All right, so what I'm going to do really quickly is I'm going to import the necessary libraries that we're going to need today. So NumPy as NP, as well as obviously Pandas as PD. I'm going to use the PD read CSV file and import the Titanic dataset here. And I have all that, which is right. And so what I want to do is actually save this whole thing into a variable called data. So we're going to be working with this variable during the entire notebook, right? And so to investigate the first few rows of data, you kind of just saw that, but I want to cover a function that allows you to do this more explicitly. So what I'm going to really do in the next few minutes is show you three things that I always do to explore data when I first import a new data set that I haven't seen before. So the first thing I like to do is just to display out the first few rows of data. And how we can do that is actually just to use the data.head method, which will output and display the first 5 rows of data. And that's what you see right here. So just to take a look at that data, we have passenger ID, we have a survived column. So basically, it's a denotion of whether or not this passenger that boarded the Titanic, whether or not they survived. 0 is that they did not, and 1 is that they survived. The class ticket fare they got, so first class, second class, and then third class. Their name, their sex, their age, and then a few other things that we're not going to actually use today, so don't worry about it. But what this head method does is it will display the first 5 rows of your data. So to get the last 5 rows of your data, or the last 10 rows of your data, you can just use the tail method here. And so by default, the tail method will give you the last 5 rows of the data set, right? But if you wanted the last 10 rows, all you would need to do is type in 10, right? If you wanted, the last, say, 8 rows of data for whatever reason, you can just type in 8. So it's really flexible with what you want or how much data you want. So I'm just going to get the last 10 rows of data here. All right. So that's the first thing I do. I look at the first few rows of the data and I look at the last few rows of data just to see that, you know, what I'm seeing is correct. I did in fact load the Titanic data set. The next thing I want to look at is really like the data types and all the columns and all the non-null values. So what I can do is I can use the info method. And what that's going to do is it's going to go through the entire data set. It's going to pick out all the columns that's in that CSV file that I imported. So I have 12, right? 12 columns. I have all of these non-nulls. So in the passenger ID column, I have 891 non-null values. And then it's actually saying that in the age column, I actually only have 714 non-null values, which means that I have over 100 missing age values in this data set. And then same thing for cabin. I only have 204 non-null values. So that's really important for me to understand what this data set is and where the non-nulls are and where the nulls are as well. In terms of data types, I have the data types here. I have 64-bit integers, floats, and objects. And this is really important for me because I need to understand whether or not the data got imported correctly. So oftentimes, like there are, columns that are like IDs that should be numbers, which it is right here. It's an integer, which is exactly what I'm expecting. But sometimes there's like an extra comma or a leading or lagging like white space, where it turns, Python doesn't know what to do with it. So it turns the integer to an object. And, that's not good for trying to run statistics or trying to aggregate and apply like, averages and maxes too. So you have to clean up that data. You have to strip away the extra commas, strip away the lagging and leading like white spaces to force the data type into a data type that you want, which in this case would be like an integer or a float. The last thing I want to cover is just summary statistics on the data set. So you can use this describe method here. This will give you essentially, the count, the mean, the standard deviation of all the numerical columns. And so as you can see, there actually are only 7 columns here. These 7 columns are the columns with the data type either int or floats, and it's just going to ignore all the object columns, which makes sense because you can't run summary statistics off of non-numbers, right? So I don't typically like how this is displayed. I will transpose it. To me, it's easier to look at when all the columns are actually rows and then you have the summary statistics up here as columns. So I'll do that just to take a look at how the data is described. So all in all, these are the 3 things I always do whenever I import a data set. I will always take a look at the first few rows of data, just as you see here. And this is really just to evaluate whether or not I actually did import things correctly. This info method is, to me, the most important one. I want an understanding of all the columns I imported. I want an understanding of how many nulls and non-nulls there are. And then I definitely want an understanding of the data type and how Python read that column in. Did it read passenger ID as a number or as an object? So that's really important for me because it's going to guide how I clean up that data. And then lastly, I just want to look at the summary statistics. This to me isn't super important, but it's important just to understand how the data is behaving, like whether or not there's a huge standard deviation, whether or not there are huge outliers, or any of that, any of those types of questions. So with that, let's actually dive into just common filtering methods that we could use to filter and aggregate data using pandas. So to filter out data, like we have data that looks like this right now. And maybe we just want to filter the data for men. right? I just want to understand, I just want to get a list of all the males that boarded the Titanic. How would I actually do that? In Excel, you have column headers, and you can filter off column headers that way. In Python and in Pandas, you have something very similar. And the way to do that is to create a Boolean mask. So a Boolean mask will isolate a column. So we want obviously the sex column, and we want to isolate the value male, right? Because that will give us all of the males. If we create this Boolean mask here, run the line of code, we basically get trues where the passenger is a male, and we get falses where the passenger is not a male, it's a female. So we take this Boolean mask and we just put it in inside the data. And what you will get now is the data set with only the males, right? So this is the filtering method that makes Pandas pretty powerful, is that you're able to filter data pretty easily based off the value that you find in the data. So just to follow on this concept, sometimes this is too much, right? Maybe you want to just isolate the age for whatever reason. Maybe you want to get the average age or the max age of passengers on the Titanic. So in order to do that, if I want to filter the ages for the men, what I can do is, let me just copy and paste this line of code and put it down here, which will give me this whole thing. And if I just want to isolate this age column, it's actually really simple. I'm just going to put dot age. So I'm just going to say from the dataset, from the Titanic dataset, I just want the age column, and then just give me just the males. And if I run this line of code, I get just that. I get basically all of the males that was true, and I'm getting their ages here. Right? So this is how you would filter out different logical statements like male or female, and how to isolate certain columns in your data set. That in itself is powerful, but not really valuable. And so what's valuable is to answer some questions such as how many men and women were on the Titanic, what's the survival rate of adult men. That requires filtering like you see above here, but it also requires mathematical operations to be added onto that. And so that's what we're going to be covering. So let's try to solve this problem here. If you know a little bit about Pandas, I would actually press pause and then try to answer these questions by writing code, and then unpause it to see whether or not your code matches my code. All right, if you don't know Pandas very well, I suggest you just follow along and watch how I do things. So what I'm going to do is filter out the males first, and then second I'll do the females. So we already did the males before, and all we had to do was create a Boolean mask to isolate the males, and then put that in the data set. Whoops, so it actually should be male, and I get that, right? And then what I don't want is this whole data set. I don't really know what to do with that. So what I'm gonna do is just filter out, well, what I'm gonna do first is I'm gonna just count all the rows. And what I can do there is just type this count method, which will count all of the rows in the data set. And what it does is it actually counts all the non-null values in the data set for all of the columns. That's why I have 12 columns here. And I see that for the majority of the columns, there are 577 males. And then there are some missing values in this age column here, and some missing values in this cabin column here. That's it. To answer this question, we don't actually want that. To answer this question, we actually want the output of 577, right? So in order to do that, you actually need to isolate one column. So you can pick a column at random. I'll just pick the same column, the sex column. That way I get one number, 577, right? So if I now were to get the survival rate for adult men, what I would need to do is I need to filter out based off of two logical statements. So the first one I'm going to copy from above is males. The problem is the males, they're children that are male and there are adult that are male. And I need to somehow use this age logic to filter out only the adults. So what I can do is I'm going to put parentheses over this. I'm going to type in age because we know that there's an age column, and I'm going to write greater or equal to 18. And I'm actually going to put that in parentheses here. And then I want males, and I want all the males that are over 18. So I'm going to use this symbol here, which is, I'm on a Mac, and so it's like Shift and 7 will give me this symbol. That is saying that I want the males and males that are ages 18 or older, right? And so this here is my Boolean mass. And if I now do a data, put the Boolean mass in the data Pandas data frame, I will get a data set that is only adult males, right? But I want to get the survival rate. And to get the survival rate, I need to leverage this column here, this survived column. 0 is they did not survive the Titanic, and 1 is that they did survive the Titanic. So when I think about survival rate, I think about the metric itself. So the metric itself, I'm going to type out, it's really equal to the number of ones divided by the total passengers, right? Right. So another way of saying it, instead of the number of ones, it's the number of survivors divided by the total passengers. Survivors and non-survivors, right? So another way of also saying this is, because this is a bunch of ones and zeros, we can get the mean of that, and it's going to actually give you this formula. So what I'm going to do is I'm going to use the mean method. So it's getting the average, and I want to get the average of the survived column. So I'm going to isolate the survived column here. So what that's going to do is it's going to calculate what the average is of the survived columns, because it's, 1 or 0. And it's saying that about 18% of adult males survived the Titanic. So how would we then use this? How would we then use that to calculate the survival rate of women and men? Well, we can do basically the exact same thing. We can create a Boolean mask, and then we can apply the mean or the average to the survival or survived column. So the trick actually is to create the correct Boolean mask. So I'm gonna actually take this Boolean mask here, so we can just copy and paste. Obviously, this is gonna be female. That's the easy part. And then we're gonna flip this inequality sign to less than 18. And I'm going to delete this equal. So we just want ages less than 18. Is this the right logic? Well, individually, yes. We're capturing the females, we're capturing children. But this is actually what this symbol is saying, that it's saying that we want female children, right? We want female and we want children. So they have to be true for both statements, meaning that it's only going to give us female children. But this question, what it's asking for is both women and children. So both adult women and children, adult children, and both female children and male children. So the symbol you need to use is actually this OR symbol here. And again, on a Mac, it's Shift and it's the button right above the return button. This gives you the OR symbol, which means that I'm looking for females or anybody that's younger than 18. So if this Boolean statement is correct, I'm gonna then apply it to my data set. And then I'm going to also isolate just the survived column, and I'm going to find the average of that so I can get the survival rate. And what I get is 68.8%. So it's almost 69% of women and children survived the Titanic, right? So this is basically just creating the right Boolean math and applying the correct, aggregate or mathematical operation to get some statistics out of that. We can also use the group by method to make things just slightly easier for us and aesthetically pleasing. So if we wanted to basically figure out the survival rates of both men and women based off of what I just covered in the past section, you would have to write 2 lines of code, right? You would first create a Boolean mask for the males, and then you would find the females and create a Boolean mask off of that. And then you would end up with 2 lines of code and 2 numbers. There is a way to do this all in 1 line of code using the group by method. And so the group by method basically it requires a categorical value. And another way of saying that is a categorical column and a numerical column. So the categorical column in this case will be sex, so the gender, and then the numerical column would be the survived column, right? And we're going to use the group by method to basically do this whole thing in 1 line of code. So I'll show you how to do that now. We'll take our data set, we'll use our group by method here, and inside this parentheses, we're going to add the categorical column. So we're going to add sex here. And now we need to add the numerical column, right? And to add the numerical column, we're actually just going to use brackets. So that's going to be survived. And then on top of that, we want to add in basically the method of aggregation that we're interested in. In our case, we want to find the survival rate. So we actually are going to use this mean method, and I'll just copy it down below. And what that gives us is the survival rate of the females and the survival rate of the males, right? And all in 1 line of code, and it's actually displayed pretty nicely. So another question is, well, what if you want to cut the data with multiple categories? Can we actually do that? So the answer is yes, we can definitely cut the categories or add in multiple categories. So in this case, maybe we want to use 2 categorical columns or categories. We'll use sex, and then we'll use P class. So this will give us an understanding of how gender and your ticket, whether you had a 1st class ticket, a 2nd class, or 3rd class ticket, how that affected the survival rate when you went on the Titanic. All right, so in order to do that, it's very much the same syntax as above. So actually what I'm going to do is copy and paste it. And then the only change that you need to put is you need to add another categorical value, right? Categorical column, which is P class here. The only difference between the top line and this line here is not just an extra P class, an extra column, but because we have multiple values in this parentheses, we're gonna have to add this brackets here, right? So that's the only difference, is just adding the bracket for multiple values. And if I do that, I'm now able to split the data by P class. So it's basically what it's telling me is on the Titanic, females that had a first class ticket survived 96 to 97%. So 97% of females that had first class tickets survived the Titanic. Whereas 50% of females that had a third class ticket survived the Titanic. And even worse, almost 14% of males that had a third class ticket survived the Titanic, right? And so with one line of code, we were able to slice and dice this data set and produce pretty surprising and interesting statistics.